Hey there, Tristan here. Let's talk about 2-wire and 3-wire sensors. 3 first because it's easier to understand. Now, the two sensors in question might be a pressure sensor that has 3 wires, and you expect one to be a 5-volt feed or a 12-volt feed, a signal wire to the ECU, and a ground. That's pretty common. To be clear, we're not looking at PWM wave signals. We're just talking about voltage signals back to the ECU and how that works. So let's simplify it to the easiest way to understand it. There are really only 3 things that can exist. There's a ground signal, there's a positive signal, these two are literally correspond to what's on the battery, and a literal signal back to the ECU that's telling the ECU, it's communicating to the ECU what the sensor wants the ECU to see. So the ground is constant. It never changes. The positive could be different volts, right? So the battery of the car is right around 12 volts. The alternator puts out right about 14 volts. A lot of your sensors work at about 5 volts. That's all designed that way. And you'll understand why most sensors are 5 volts hopefully by the end of this video. And then the signal is literally the ECU is just looking at the voltage on a line. It wants to see is the voltage up to 5 or down to 0 and anywhere in between, and then it knows what to do with that corresponding value. So if the value the ECU sees is 3 volts, it knows that it's right around the middle. And it'll output either a position on a gauge or a number on a readout. But now to understand how this sensor works from a fundamental perspective, it's easier to think about it initially as a voltage regulator. So a little lesson on electronics in a car. This is a DC system. Automotive manufacturers figured out a long time ago we can't really rely on 12-volt systems because there's so many fluctuations. So they had to pick a lower number. They picked 5. So a lot of times your car is using voltage regulators to drop the voltage from 14 or 12 or whatever high number might be down to 5 volts. And that 5 volts is what a lot of sensors use. Now the way a voltage regulator looks, it looks kind of like that. It's this little diagram. I don't have a physical one. They can be very, very small. And all it's really doing is you have an input, an output, and a ground. So the input is the 12 or 14 volts from the battery. It could be obviously high amperage, but these guys cannot handle high amperage. So there'll be some sort of resistor beforehand to drop the amperage. That 14 volts will come in, and then it's bleeding off voltage to the ground. So in this situation, 14 in, 5 out, what's the math there? That's 9 volts that it's bleeding to ground, and it's allowing 5 volts to travel out the other side. That is the most simple possible explanation, hopefully, of a voltage regulator. Now, that is literally no different than how this sensor works. So this sensor is getting 5 volts in, it's bleeding voltage out to the ground, just like the voltage regulator, and the output to the ECU corresponds to this pin. I guess I could have swapped the green and the black just to make that even a physical correlation. But essentially, this ground and this ground are the same. It's bleeding voltage from the input to the ground, and this sensor is using the output as a signal. That is all it's really doing. So that voltage that is regulated, in this case, it's a consistent output. In this case, there's just a little sensor there that's saying, if I see low pressure, I'm putting out one type of voltage, it might be high, and if I see a high pressure, I'm putting out a low voltage. That voltage hits the signal wire, goes back to the ECU, and now the ECU can tell what that sensor is seeing. So what happens on a 2-wire? Well, a 2-wire, again, simple understanding, ground positive signal. Sometimes the 2 wires call it a pull-up sensor, and they use a 2.2K resistor. So you've still got your ground wire, but then you have what I've represented here with a green and red dashed line. And I chose those colors because it literally correlates to a positive and a signal. So what this sensor is looking for is a voltage coming in and a ground to bleed the voltage to. So in this situation, you might have 5 volts coming in, and it's going to bleed just like a voltage regulator, that voltage off to the ground. But now it's using this input line as a signal as well. So technically, what you would see going into the sensor is 2 wires. One wire goes back to the ECU, and that would be your signal. The other wire is what we call a pull-up resistor 5 volts. So this is a 5 volt power supply, but we're going to put a resistor in line at 2.2K ohms. So I'll do that badly. But all it's really doing, all that resistor is doing, is taking care of the amp side of things. So the voltage regulator takes care of the volt side, the resistor takes care of the amperage. And that's just our little simple equation up here. Watts is the amount of energy something requires. Watts is equal to amps times volts. So in this situation, we want a tiny amperage. So we've already got a voltage regulator back here. It goes through a resistor to drop the amperage. That way we don't melt this sensor and we don't melt your ECU with the massive backload. But the ECU can tell on this line, if it is 5 volts and this resistor is high, it's basically how this is working, all that 5 volts goes to the ECU. If the resistance here is low and all the voltage is going to the ground, then the signal is low. So in both cases, it's really just a ground positive and a signal wire that you're using to understand how these two sensors work. Voltage regulator does exactly that, regulates the voltage. A resistor could be called, technically, the way my brain at least thinks about it, as a amperage regulator. Thinking about it this way, it's very easy to understand how a 2 and a 3 wire sensor work in a vehicle atmosphere.